That's okay. Here we go. Number 2. It was just asking for the models for logarithmic graphs. No big deal. Number 4, it was asking for the model of logistic. You guys should have been able to pull these straight out of your notes based on the shapes of the graphs, right? Number 10. I think we talked about at least part of that. So check your answers. Did you guys get 11.0%? It was a decimal, changed to percent. For R, and then 6.3 years, about. You could have had some more decimals. That's okay. For T? Good? Gavin? Oh, remember you would have had to time to double. We set the new population to be twice as much. When you divide by 500, you get 2. ln both sides, ln 2, and then divide. Does that make sense? Okay. Number 24. This was is this one of those radioactive ones? Okay. I think I gave you like 1 even from the finance table, 1 even from the radioactive one. Maybe 2. Using the clues from yesterday, hopefully you guys could have gotten down to, now they went ahead and just gave it as a fraction. You could have gotten it as a decimal. So you can check your work for just a second. I'll throw in really quickly the expression, even though I know some of you guys probably have it. As a decimal, if you were checking it, it would have been 2.876 times 10 to the negative 5, which would have been 0.0002876. Maybe you see why they left it like that. They're like, eh. And then once you know that that was your B, you could plug that into your equation with all the other information. You could say, hey, my 0.4 grams is how much I have left when my year is 1,000. Solving for A just requires a division by this nasty, nasty, nasty e to the. You end up with approximately 0.41 grams. Approximately 0.41 grams. That's number 30. So let's just keep going. Number 34. Number 34. This one was a little weird. You could have plugged in, they gave you 2 different times. So you could have plugged in the 2 different times, and what they did tell you was this 10-hour one ends up being double this one. So you could actually make a little equation and say, oh, your amount is double your amount. Oh, your amount is double your amount. They took the statement and they made it into a mathematical expression, at which point they were able to multiply and then divide. Actually, I would have probably gone that way. Divide to be 2, divide, you subtract the exponents, and then it's a quick solve, solve, solve from there. But once again, 2 different clues with 2 different times. The statement, the clue in the problem said the later time has twice as much, or the population is double the amount in the beginning time. That got us our expression to solve for B. Once you know B, you can plug it back into your equation with 250 being your initial, and you can solve for whatever they want. They want 6 out? Fine, plug in 6. Dun, 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 dun. 397 bacteria. There probably were decimals. Why do you think they might have rounded that one to a whole number? Yeah, it's number of bacteria. So they just went to a whole number because that's the only thing that makes sense. If asked for how many people, how many elk, how many college students got sick, whatever the example is, how many bacteria, we usually go to a whole number. Okay, 48 was kind of a mess. You're not going to see anything that hard on the test for number 48. It was basically asking you to compare, and you really had to use the directions in order to help you with that. I'm going to actually go ahead and, for right now, skip that one and talk through it in just a second. It's going to be a lot easier if we just talk through, because I know a lot of you guys had questions on 48. Number 52, maybe you didn't realize how easy it was. You were literally just taking, what is that, hydrogen? You were literally just taking him and plugging him into the formula and saying, sweet, calculator, done. They gave you a formula. You were just plugging it in and saying, oh, just take the negative log of blah, 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 done, 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 done. How do you do scientific notation in your calculator? Yeah, E would probably be the easiest way. Tony, what's up, bud? I always go to 3, so I know the book is inconsistent. I don't like the book's way of doing it. I always go to 3 because of an AP calculus, but on a test it could have 1 to 2. Just make sure it matches appropriately with where it should be rounded. Does that make sense? So don't worry, don't take off, or don't mark yourself wrong on the decimals. Let's say you went to the nearest whole number, you should have 5. Let's say you went to the nearest 10th, you should have 5.0. Let's say you went to the nearest 100th. Okay, is it 4.94 something, or 4.951, etc.? You're probably okay. And last but not least, number 66. I think you guys were just looking at graphs and saying, it looks like, right? Letter A is logarithmic, letter B is logistic, letter C is an exponentially one, letter D is just a linear. I know it's not from the section, but it's just a line. Letter E is none, because it seems to be part line and part quadratic. You could have said piecewise. I guess that would have been okay. Letter F, exponential. Letter G, quadratic. I know, not this section, but once again. And then letter H is the Gaussian bell-shaped curve. All right, let's go back to number 48, and then I'll take other questions, okay? Let's go back to number 48 real quick, because he was weird. It was actually really easy once you figured out what was being given to you. Or was a panda bear? Should have done that one. Okay. Where's 48? You guys realize there was a huge paragraph of given information, right? Okay. Because if you didn't realize that, you were in some big trouble. Like you were kind of sunk before you started. All right. What's the given information? What did you guys write down as the most important stuff from this paragraph? Okay, so B with decibels. Intensity is I. Is given by, yeah, this equation looks kind of important, right? I0, they tell me what it is. Corresponding roughly to the faintest sound that can be heard by the human ear. Oh, it's kind of cool. All right. So for this entire thing, we're using beta is equal to, that's a nasty beta, but apologies. And then we have I times, right? Okay. So what's going on? Find the level of sound B. So for letter A, a faint rustle of leaves, how do we figure out the level of sound? Just have to plug it in. So if you guys got stuck on ones, I'm just going to do one of them. If you got stuck on these ones, it was probably just you didn't read through this and realize this was just a formula. And I know the formula looks weird because we're not used to seeing betas and seeing like i's and I sub naughts. But can you read a paragraph and can you do the math necessary? They tell us what I sub 0 is, so can't we just plug in I sub 0 for all of them, right? I sub 0 for all of them is 10 to the negative 12th. Watts per square meter if you want to put the units in, but either way, 10 to the negative 12th. And then if it's the same for every single problem, what's the only thing that's going to change? That right there. So for the rustle leaves, 10 to the negative 1. And then we talked about how in your calculator, how to put in scientific notation. I'm bringing it up just in case someone got a little bit confused about that. But if you've taken, when have you used scientific notation before? Yeah, chemistry for sure. If you've taken chemistry, you should know how to use this button already. But does it make sense they gave you a formula? You plugged in the one value that was up here, and then everything else you're just plugging in one at a time. The rustle of leaves versus the jet versus the door slamming versus the siren. So really quickly, where's that scientific notation-y button? Because you guys had to use it a couple different times in homework. Let me get back to the home screen. It's here, right? How do we do this then? Oh, sorry, 10 times log if we were doing the sound level. 10 times log what? Or couldn't we just do this? Some of you guys are used to seeing things with scientific notation, but usually it's 4.2 times 10 to the, right? Or 1.936 times 10 to the, or, oh, maybe we don't need scientific notation. Can't we just plug in? Right? And then I think, guys, double check me. That was a multiply, right? Double check your formula you wrote down. Oh, see, things disappear sometimes. Thank you, thank you, thank you. If you notice on my answer key up here, literally there's nothing there, so there was no way for me to tell. That makes way more sense, because otherwise that was going to be a weird 10 to the negative 23rd. Doesn't make any sense. Okay, good. So divided by. Which, wait a minute, some of you might have been able to do this mental math style, right? Because I'm going to put it in the calculator, and I'm going to hit enter in just 1 second. But I'm going to do mental math first. Because whenever you divide like exponents, what do you do to the powers? 11 minus negative 11 plus 12. 1. What's common log of 10 to the 1? Because log base 10, right? So log is going to be 1. Oh, what's the sound level going to be? Just 10. Maybe you could mental math all of them. You could to the top and into the bottom, so 12 minus 11 is 1. I mean, or you could move that one up, and then you could just add the exponents. So negative 11 plus 12. Yeah, all the same math. Anyway, pretty cool stuff because the formula looks nasty, but you end up getting some pretty nice, pretty answers. Let's come back to homework, though. That was number 48. It might have thrown a few of you off because you needed to read that paragraph, which is why I have you summarize the directions and the problems so that you're not missing important information like that. But guys, let's start off with the odds because those are the ones that you knew the answers to. You were able to talk in your groups and look at Calc Chat. Are there any odds that we're still kind of stuck on? Yeah. 25? Okay. Let's go peek at 25 real quick. And then for those of you guys that know how this normally goes, have some even questions ready if you are stuck on them. Okay, number 25. Great question, Robbie. We didn't do an example like this yesterday. The directions say, find the exponential model that fits the points. Okay, go ahead and zoom in on the actual given info. Exponential model. Did anybody figure out what equation if it said exponential model? How do we know it's a positive bx and not a negative one? Yeah, look at this swoop. It's just a normal swoop. Swoop, there it is, right? It's growing. Well, what do we do for number, it's still number 27. For number 25, what do they give us? Who are these guys? Oh, x's and y's, right? But two different ones. Okay, let's use this as our model. Let's use this as our goal. Let's plug in two different points. So I could plug x's, and when y is 10, x's. Which of these looks like something pretty I can solve? Yeah, because what's anything to the 0? That's just going to be 0. What's anything to the 0 power? Oh, so I could just say 1 equals a times 1. So I can kind of cheat on that one, because if I had the 0, that e to the b times is going to go away to b1. And once I know a, what can I do with this guy? Plug it in, right? So I can say, oh, 10 doesn't just equal a times e to the, it's 1 times e to the 3b. So divide by 1, you still have 10. How do I get rid of that e? Right, the inverse property. So I end up with ln of 10 is equal to 3b, which means b is equal to got it, Robbie. Now they did say find the exponential model. These are just the pieces to the model. I need to come back up here and say, all right, plug it in, plug it in. So y is equal to a is 1, e to the 1/3 ln of 10 times b. Oh, sorry, times x. My bad, wrong variable. B just got plugged in for. Does that make sense? So what they meant was get the equation with all the good stuff plugged in, aka all the constants plugged in. X is allowed to stay. It's a f of x. Y is allowed to stay, but I need to get everything else figured out. Okay, any other odds, first of all? Evens. Kyle, what was yours, bud? Okay. After this, I'm going to quickly go look at number 30 just in case anyone does need to check those answers. Actually, let's just be honest. Anybody need to check number 30? Okay, then we'll skip it. No, it's all right. It's all right. I had you skip it on purpose. It's not on the test tomorrow, that's for sure. All right, here we go. The number of bacteria in a culture is increasing. Increasing! Looks like exponential growth to me. And if you want, you can be thinking about, remember, this kind of helps us as far as who's what. Amount of bacteria. P, principal, beginning population. R, rate, percentage, decimal, something weird. T, time. Anyway, number of bacteria is increasing growth according to the law of exponential growth. Oh, hey, there it is. The initial population. Okay, where do I put that? Yeah. The initial population. So I can go ahead and say, okay, well, hold on. So A equals 250. E to the R. No. Okay. T. Yeah, but not a T for all time. It's just a specific T. And the population after 10 hours is double the population after 1 hour. Okay. Remember how A stands for the amount of bacteria? Couldn't I change this statement to say the population, the amount, is double the amount? Does that make sense? The amount of bacteria after 10 hours is double the amount of bacteria. That sounds like an equation to me, cool kids. So how do I make an expression that stands for the amount after 10 hours in order to plug in to double the amount after 1 hour? Well, we know this is our equation. So amount after 10 hours is going to be 250 e to the, I don't know, r, but 10. Does that make sense? So the amount after 10 hours, this expression 10 plugged in, is going to be, is double 2 times the, well, the amount after 1 hour is this, but with t being 1. Once we have that, we have a little equation. We can do some math too, because we're going to have 250 e to the 10r. 2 times 250 is e to the 1r. That's kind of boring. I can divide by 250. Is equal to 2 e to the r. I can divide by e to the r. When I divide like bases, what do I do with exponents? Now I can ln. Now CalcChat or even the answer key that we just looked at a second ago would have called this not R but B, but do you guys see it's the same thing? I just like the R because it's rate in my head. It makes more sense. Wait a minute. Look at the question at the end. How many bacteria will there be? It sounds like they want another amount. They don't want R, so why'd I do all that work? Yeah. I just don't need a 6. So I need to take my 250 e to the, oh, I need r to plug back in. I like doing a little 1/9 in front. I don't know. When it's in an exponent, that's hard to write, so I just do it that way. But I do my r times my t, which is 6. There's my r. There's my t. Sam, plug it in. You're good. Plug it in and you're good. It was all about translating. Okay, I'm not going to take tons more time, but is there one other question I can do, odd or even? Yeah. What I did is instead of doing ln of 2 divided by 9, I put 1/9 of ln of 2. Because I like when I'm putting it in a power, I like writing it like all in one line and not having to do like a fraction, because a fraction starts to look confusing in a power. Because we had to plug in t. And yeah. Okay. Let's go peek at 24. Okay, I'm going to go ahead and pull up that page from notes that we did yesterday because we started talking about the tables with the radioactive decay. Oh, it's this one. Perfect. Let me do a quick new page. dual screen it. Okay. So for number 24, it's the same idea of having a half-life, an initial, and amount after 1,000 years using our exponential decay equation, which is this guy, but you can think about PERT again if that helps. Let's go check out the clues that we have on number 24. It's, what is that? Is that polonium? What's Pu? No, polonium's Po. No? Oh, come on, my chem kids. What's Pu? That doesn't matter. Doesn't matter the name. Ah, so let's not stress. Oh, plutonium. I should have known that one. But the name doesn't matter. What matters is the given information. So we have half-life and we have amount after 1,000 years. So keep me honest, kiddos. We have 24. Oops, wrong one. Okay. We have half-life. Check it. Is it 24,100? Okay. We don't know initial, right? We do know amount after 1,000 to be 0.4 grams? No, what was it? Oh yeah, that's right. Oh, this thing decays. Wow. I was going to say it decays a lot faster. It does decay a lot faster than like the one up there, than carbon. Oh, it makes sense that carbon takes a long time to decay. Carbon-14 dating, anybody? Anyway, coming back.